Hi, good afternoon, good evening. I'm Brent Gorda, and I'm the Senior Director for High Performance Computing here at ARM. ARM is a bit of a new entrant into the high performance computing market, and we have a bit of a different offering than has typically been in the community for the last 10 or 12 years. The main technical feature that we've introduced and that's been embodied with some of our partners is the Scalable Vector Extensions, SVE. This is a really good implementation of vectors for microprocessors, and it's done in a way that is vector width agnostic. And so our partners are able to select the size of the vector that they want to implement in their hardware, and your applications will run on that hardware without change. So this is a boon to those ISVs that are out there trying to produce one binary that will run across the entire ISA platform. Backing up, the big feature that ARM presents to the community is that of a different business model. ARM is an IP company, and what we sell and license is our ISA, the assembly language, if you will, and then implementations of that assembly language. So you can get what's called an architecture license, which is the right to implement that assembly language, or you can buy what's called the Neoverse product from us, which is the implementation of that IP. Where this is important is that we've also got a standards test that is called System Ready. And if your implementation matches that standard appropriately, the whole software stack on top of that will function. Now, functioning means it will run correctly, and there may be some performance tuning that you want to do, but to first order, that entire software stack will run for you. Where this is important, especially in high performance computing, is that we've got a good number of partners that are doing Neoverse implementations, as well as some that have done their own architecture implementations. And they're taking advantage of the groundswell of activity on the software side, so they can focus on the hardware and know that when they come to market, there'll be software and support available for them. Last time I looked, there were 7 Linux operating systems as well as Windows that were supported on ARM, starting with SUSE and Red Hat. So when you build your chip and put it in a system, passing the server ready process means that all of that software should run for you. Now, the architecture license has recently been made famous by Fujitsu and the Fugaku system. So currently the world's fastest machine is an ARM design, but it's an architecture license where Fujitsu has done their own implementation. Back up a few years, there was Marvell and the TX2, which really propelled us forward and got us on the top 500 in the first place. Looking forward, you're seeing HPC architectures blossom in nature. And this is in part because the way our IP license works is we give you the opportunity to improvise inside the socket. So it's really innovation inside the socket. If you take a look at what South Korea is doing, for example, they've got an accelerator that's mature, and they've taken a license to the ARM Neoverse V1 implementation, which was called Zeus, if you've been following along, and they are tying their accelerator on chip to the V1 implementation of the core from ARM. So they get the entire software stack out of the box working for them with implementation, and then they get to put all of their weight behind their accelerator that gives them the leg up for the particular workloads that they're working on. As we learned last week, NVIDIA is talking about a future chip called Grace, which is based on an ARM implementation. We've been hearing for a few years about Silicon Pearl, which is building a processor for the European Processor Initiative in Europe. And there's more in the works and more coming. Interestingly, in this market, which bleeds over into the server market, a lot of the companies don't want to be public about what they're building. They're just working with ARM. They're building a new and novel and incredibly more efficient and performant offering for the market. And you'll be watching and seeing these come to market over the next few years. So ARM in HPC is doing really well. It takes a few years for this hardware to come out and stick and happen, but I have all the confidence in the world that ARM is in HPC, and with our partners will be a dominant factor in high performance computing down the road. Thank you.